The semiconductor companies need to do more and more of the legwork. And that's what we try and do with the modules, right? We try and integrate as many things as possible into a single package, give you as much flexibility as you can, help you as much as we can along the way to make this transition as easy as possible. You can take our knowledge with EMI and also our DRMOS knowledge for being able to deliver this high current and put them together for these new edge AI and industrial applications.
These new things that design engineers are facing with edge AI and all the complexities of systems, you've got power solutions to help them manage that much more complex environment. Hello IPXers, we are at Embedded World 2025. Said that very quickly, 2025. I don't know about you, but do you feel different in some way? Do I look different? Is there something different about me? Where are we? Who are you and where are we?
My name is Thomas Hudson, and we're at MPS, at the MPS booth at Embedded World.
That's where we are. What should we talk about? I think we should talk about the coming storm of AI and how it affects all systems and how particularly it's going to affect power. Thomas, tell us how, from MPS's point of view, the whole AI coming storm is going to affect your world and therefore your customers' world in managing power.
Well, I think AI is becoming more and more important and is being placed at the center of applications where previously it might not have been. Such as, for example, we've seen more and more FPGAs being used in applications that we didn't used to see them at all.
Right. Give me some examples of those.
In the industrial market, we've got smarter and smarter machines, we've got more industrial vision, and we've got, therefore, to adapt the power trees to the voltages that we see in the industrial space. Right? So higher voltages coming off of 24 volt buses, 36 volt, 48 volt buses. And that's something that we've tried to adapt through reference design to new products for this sort of change in the industrial segments.
Right. So because when we've been wandering around the show and we're talking to people all the time, we're obviously talking about predominantly edge AI applications, and we're talking about therefore all the processing being done, machine learning being done on and in the device. That's obviously going to have massive implications for the power management. Yeah,
no, definitely. That's why we've developed, for example, some of our new models where we incorporate the high input voltage with also the requirements on the voltage regulation, on the configuration. These devices get more and more complex, they require more and more power. And therefore, we need to be able to configure the output voltage to the millivolts, so to speak. We also need sequencing. We need tighter safety on the output voltage. You don't want to have an unexpected voltage spike that can ruin a very expensive FPGA or ASIC.
Right.
So we're joining the wide input voltage range.
So it's not just the system power that you're managing. Exactly. It's the on-device power that you're managing.
Well, MPS in general, our idea is pretty much from the grid to the socket, we can do every single step of the way.
Right.
You know, from our AC/DC team to being able
Sorry, but I've never heard anybody from MPS say from the grid to the socket.
Well, it's my own.
Is that an exclusive for IP Exchange today?
Yes.
From the grid to the socket.
From the grid to the socket. There you go.
There we go. Right, tell us how then that affects what you've got to show me today about your industrial markets and power management.
Well, yeah, as I was saying, if you want to power an FPGA, but you're coming off a 36 volt bus, usually the way that we've been doing it up till now, the types of point of load converters that are converting down to the 0.8 volts that you need for a core voltage have a limit on the input voltage of, say, 12 volts, or designed for 12 volt rails, or they're designed for 5 volt rails. We've developed a series of products that can take the 36 volts straight down to the 0.8, 0.75 volts that you need for powering that FPGA. It also includes the PMBus, so you can regulate all the sequencing when you turn it off and you turn it on in a safe way. And you can also change the switching frequencies, because that's also very important in the industrial sector. Some people want to have different switching frequencies on the same board so that they can sort of have a spread spectrum of emitting frequencies. You also have the advantages of being able to read back the output voltage, the output current, and the heat of the junction temperature inside the module, because these machines usually get really hot, so you need to be very careful that you're within the right limits. So all of these things, synchronizing the frequencies, because in some cases they want to have them spread, sometimes they want to have just one single switching frequency, one single rising flank. So all of these things that usually weren't applied to this sort of market now are. So we need to adapt accordingly.
Yeah, no, that's very interesting, because when we've been going around the shows, it's been very clear to us that there's a pre-2022 legacy industrial electronics, or any kind of electronics actually, but we're talking about industrial electronics in this particular case, and then there's a post-2022 electronics, and there is literally a slamming door, which is all about legacy, and then is all about managing how AI. So you just used a phrase which was from the grid to the socket. So, but in actual fact, when you ended up talking about that, you ended up talking about a lot of stuff. You talked about, so historically, if we were working in industrial electronics, particularly in this country here, Germany, there would have been, you were very comfortable in explaining how everybody understood the parameters. So let's just say everybody understood the parameters up to 2022. And then what you're saying from MPS's point of view, when you go post 2022 and there's the coming storm of AI, it's not just the management of the power, but it's the management of the power and the devices that are in the system, which were never there before because you weren't having to managing that kind of data. So I'm just to making sure that I remembered everything that you've said. And then because you've got so much more going on, you've got heat to manage as well. So there's a lot of complexity that you're describing that is facing design engineers from 2022 that never existed before 2022. It might as well be a completely different set of parameters with your design.
Yeah, well, I think that the baseline parameters are still the same, right? The problem is that with every iteration, technological advancement, or every time we call a new industrial revolution, I don't know what the 5th industrial revolution or the 6th, industry 6.0 or 5.0.
I've lost count.
We keep adding essentially more stuff in the same space.
Yes.
So there's more computing power, there's more regards for safety, it all gets more complicated. So you've got to deal with more things. More things you need to deal with, the simpler the solution that you use needs to be, in essence. So the semiconductor companies need to do more and more of the legwork. And that's what we try and do with the modules, right? We try and integrate as many things as possible into a single package, give you as much flexibility as you can, help you as much as we can along the way, to make this design or this transition as easy as possible for these industrial applications, and for any application in general.
So do you want to just show us now how that exemplifies itself with products that MPS have got with what you've got here?
Yeah, sure. For example, this converter here, 3599, it can have a dual 12 amp output, so two 12 amp outputs, or a single 24 amp output. So for powering these sort of mid-high current core rails, which can also be put in parallel if you need even higher current. It's completely configurable. There's loads of digital aspects inside this converter, which for a 45 input voltage converter, they usually don't have this digital interface. Then if we go down for slightly lower current for the 6 amps, this converter, the 3596, which is just a 10 by 10 millimeter package, by the way. So for these really space-constrained applications, that's important. And for the scalability. So right now you're using a certain generation of SoC. You go to the next generation, you need twice as much power, twice as much current. So this one you can parallel up to 6 of these together, so you can get up to 36 amps. Just using the 3596 in parallel, you get smaller ripple, you use fewer output capacitors, get higher efficiency. So all of these things that are required for powering these ASICs and SoCs for AI in the industry.
Yeah. So if we just quickly start from the beginning, would these not have been a solution pre-2022? These would not have been products that you'd have had in the product portfolio?
Well, these parts were thought of so these were in the roadmap in 2022. We've been developing them as we've seen these trends start to change. What we need to, as I said before, we need to accompany any changes that we see in the market
Yeah.
with these new products.
Yeah.
But yeah, all these products are, most of these products are new from last year or this year.
Yeah.
And we've still got a whole series of the roadmap to come.
Yeah. The reason why I asked that question is because where we started the interview was we were describing this extraordinarily complex power, not going to use the word power hungry, but different power parameters that people have got to manage that they weren't managing. So they are, when we talk about legacy design, they would have been things that they understood, that have been things that they knew were there, they were understood knowns, if you know.
Yeah.
Now, many design engineers will be looking at problems that they're going, oh, that's new. I've got a whole different set of things that I've got to do regarding the power. And what you're saying is, if they come and chat to you at MPS, you can help them understand that more complex, be that with AI or with FPGAs or whatever else they're managing within their system.
Yeah, it's sort of joining both our legacy of knowledge in the industrial and automotive market, for example, with our also knowledge of AI, of powering these high-end SoCs, and joining these together. For example, these modules that I was mentioning before, we've got all of our EMI labs in the US, in China, and in Germany. And so we do pre-compliance testing of all of our industrial modules so that when you're designing these super fast switching with high current and large voltage steps, when you're doing all of these designs in an application where EMC is really important, you can look at those previous results that we can provide
Yeah. You've done the groundwork that they can.
And then you can take our knowledge with EMI and also our DRMOS knowledge for being able to deliver this high current and put them together for these new edge AI and industrial applications.
Right, excellent. Thank you, Thomas.
Yeah,
really good explanation about how these new things that design engineers are facing with edge AI and all the complexities of systems, how you've got power solutions to help them manage that much more complex environment. Thank you.